unlikely we're going to relate it to the bottom limit. Let's try to relate it to the top limit. Okay? So sine x over x, do you see that it's sitting in here? Pretty much, right? I see a sine 5x over x, right? Forget the cos 5x for 1 second. You see a sine 5x on x. If that was all I had, what would I want to do? Multiply top and bottom by 5. So let's do that. Limit 5 sine 5x over 5x cos 5x. Okay. As x goes towards 0. What can you do with this 5 up here? Take the outside, right? It is constant as regards to the limit. So we'll just get that little 5 out of it. We don't need it there. It's not really doing anything helpful. So 5 comes to the outside. This will help us pinpoint the limit over here that we're trying to define inside of this. So sine 5x over 5x. Now what I'd like to do is I'd like to extract off this cos 5x. Okay? Just for appearance sake. I think I'll make it clear what's going on. So to remove it off of the sine 5x on 5x, I could treat it like this. Agreed?
Why are we doing that?
So that I see more clearly the sine 5x on 5x limit that I'm really trying to focus on.
Okay.
I want to make sure that you see this piece, right, in comparison with that. This one is not going to be a bother anyway. If you think about what's happening, as x goes towards 0, it has nothing to do with that limit down there. As x goes towards 0, what does cos 5x head towards? Cos of 0. What's cos of 0? 1. So this part here is heading towards 1 over 1. It causes no problems for the limit whatsoever. It's going to work out just fine. Now, what is this piece? What's sine 5x on 5x heading towards? 1. 0, where is 0? The x heading towards 0. As the x heads towards 0, what does sine 5x on 5x head towards? According to that rule up there, since the argument and the sign and the denominator are the same, it's heading towards 1. Okay? You guys with me on that? If I made the same substitution I did up here, just for the formality of it, but let k equal 5x. Since x is heading towards 0, so is 5x. 5x is all heading towards 0. And now I can replace this with the final expression. 5. Limit as k goes towards 0 of sine k on k times 1 over cos k. Right? Again, these last couple stages are very formal, so we'll make sure that you do see here what would happen, right? This is going towards 1, and this is going towards 1. That's the important thing. So now we have 5 times this limit, but this is heading towards 1 times 1. Right? So 1 times 1, the answer is 5. Okay? So that's how you usually deal with the tan. Change the sign on cos. The sign will conform to this setup. You will use this limit. And the cos will cause no problem whatsoever. Just run a regular limit on it. Number 10. The limit of cos squared theta minus 1 over theta as theta goes to 0. Okay? So, which of these two do you think this one will involve? The bottom one. Probably because I've done 2 examples of the other one. About time I did the bottom one, right? Sounds reasonable. And I see a cos already. Now, cos squared theta minus 1. What can you do with cos squared theta minus 1? I need it to look more like this, like a cos theta minus 1. not cos squared theta. I don't want that square in there. It's bothering me. What do you say? I cannot take, if I take the root, I can't take just the root of this piece. I can't just do that. If I take the root of the whole thing, then this difference will be trapped inside the root and it will never put out the cos theta itself.
Does it happen with the conjugate or no?
Sort of. It has something to do with the conjugate a little bit. It's a difference of squares. It's cos squared minus 1 squared. There you go. So we can write it as lim cos theta minus 1 times cos theta plus 1. So those are conjugates, so that's something to do with conjugate in a way. You're not applying the conjugate rule to it though, that's not what you're doing. Over as theta. Theta heading towards 0. Okay? So now what part are we concentrating on? The cos theta minus 1 on theta. We're going to associate the theta, even though it really applies to the whole thing, we're going to associate it with that. Make sense? So now I see this limit sitting right there, right? That's the same thing? And this piece of that limit,
Can you separate it?
you want to separate it?
Oh, I don't know.
You can. That's what I did over here to like make it visually clear. Yeah, you can. It's fine.
Separate it.
Separate it after. Cosine theta minus 1 over a theta. You got that part. And you've got the cos theta plus 1 just sitting there. Theta going towards 0. 0, not 6. Really? So now we know this part heads towards 0. What does this part head towards? It is important. Because if it were infinity or something, then it might be a problem here. We'll have those cases later, but yeah. Yeah, it's heading towards 2, right? So since they're both heading towards finite values, then the result is their product. So it's 0 times 2, and that does end up being 0 in this case.
How do we get the cos
Why is
theta
that
plus
so?
1?
How do we get the what?
Cos theta plus 1.
These two?
No, well,
I'm factoring this thing. It's a difference of squares.
Squares, yeah.
So then I chose to, this thing can only go with one of them, in a sense. So I chose to put it with this one, because that conforms to this. How did we get this in the first place?
No, okay. I understand what you're saying.
Okay.
For that, yeah.
Those limits make sense so far? Everything's okay with that? They're hard to manipulate algebraically first until you see it a few times. Right? It's not an obvious thing at all. At least I don't think it is.
So we have to, so what we're doing, we're about operation
Because
has
the
to
linear
apply
goes
to
in the
and it has to
That's
be,
correct.
it has to be the same thing, it can't be different.
You cannot change. Yeah, you cannot change the expression inside. You can only change the way it looks, right? It's like any fraction. You can change the way it looks by multiplying by 5 over 5. But you can't multiply by a fifth because that changes the value of the thing. You can't change the value of what's inside the limit. That's correct. Do you need another example of that, or you feel okay with it? 11. Number 11. There's only a few problems in the textbook regarding these things. I don't know how many online there are. I'm sure they will concentrate more on the derivatives. But I will certainly ask you one of these for the next exam. Number 11 is tan 7x on sine x. If you know L'Hopital's rule, you're not supposed to be using it at this stage. You're supposed to be using these two limits over here, interpreted in terms of